Hi everyone. So we are going today here to take partial derivative. So what we have learned before, if you recall, if you have y equal f of x, y equal f of x, here your y and f of x is a f here is a function only in one variable, single variable x. Then the derivative, just try to recall that the derivative here is the derivative here df by dx. df by dx, the measures here, measure how fast, that's measure how fast, right, how fast, right, so how fast f it change, your f it change as x increase, right, as your x increase here. So now what happen if you have your f here, if you have your f is a function in two variables, so f here is a function in two variables, function here two variables, so you have two variables like x and y, for example here, two variables or more, okay, so or more, so you have more than one variable or more. Then we are going to here, we ask the same question, we can ask here, we can ask how, right, we can ask how fast f here, your f functions change at each variables, right, each variables increase, so let me write it, increase here, increase, and other variables will be fixed, remain fixed, this one here remain fixed, okay, remain fixed. So what happens if one of the variable increase and the other variable here is fixed? So this rate here, I'm just writing here that these rates here of a change, so this rate of change are called partial derivative, we call it here as partial derivative, we call it the partial derivative. So that is the definition of the partial derivative. So partial derivative, okay, partial derivative of f, the partial derivative of f. All right, and they measure these partial derivatives, they measure, I'm just trying to write here, so they measure how each variable contribute, right, contributes to the change of your f, to the change in f. Okay, that is our definition of the partial derivative. So I'm going to write a notation here. What is the notation? So the partial derivative, so that is, we call it the partial derivative here. So the partial derivative, so der, partial derivative here, right, with respect to, so that is with respect to x, is the derivative with respect to this one here too, x, variable x, is the partial derivative. It will be the derivative, just let me write it, it will be the derivative here of f with respect to that's with respect to x when other variables, when all other variables, all right, other variables, I'm just writing here, are treated as constant, are treated here as constant, okay. So let me write here as constant, and then I'm going to write the terminology here, the notation. So what is the notation? So we write it like this, df by dx. This funny d here, so means this kind of d here means your f is more than function in several variables, in 2 or more, so f more than 1 variable. So the difference between this one and d straight f df by dx like this, straight d here means f is a function only in x. F is a function only in x. But when you have this funny d, we write it df by dx. That is means you take the derivative with respect to x, and other variables, like you consider them as a constant or treat them as constant. We write f sub x like this, f sub x like this. All right, and then we could write also df, the partial derivative with respect to y. So that is f sub y. So f sub y means the partial, you take the derivative of f with respect to y, the derivative of f with respect to y, and here the derivative of f with respect to x. But when I take the derivative with respect to x, means you consider other variables, other variable are constant or treat it as constant. Likewise here, when I take df by dy, then other variable for your variable here is y, but the other variable, other variable like x, for example, we consider it as constant, okay? So that is one notation. So if I write here fxx here means that is the second derivative with respect to x. The second derivative with respect to x. That is similar to f double prime. F double prime, when you have single variable, f double prime, that is the derivative of f with respect to x, and that is usually, if you recall, we write it d square f by dx square, df is d square f. So here is the same. So the derivative, first you have to write f sub x. So here I'm going to just tell you the way that I remember, that is 1 and 2. So what is 1 and 2? 1, first you have to go ahead and find the derivative with respect to x, and then you take the derivative with respect to x again. So I'm taking the derivative twice, second time, that is our second derivative with respect to x. And likewise for f dot yy, it will be, this one I can combine them as d square f by dx square like this, and similar to this one here, but here you have straight d, but here you have funny d, means your f here is a function more than one variables, 2 variable or more. So you have fyy. Okay, so fyy here, I start from the left 1, and here 2 means you have to have your partial derivative with respect to y first, and then, so that is number 1 you should have, and then number 2 here, it will be, you take the second derivative again with respect to y. So here means you take the derivative with respect to y, but you must have in your hand the partial derivative. So that is number 1, and that is number 2. So I have to have first what is the partial derivative with respect to y, and then I'm going to take the derivative with respect to what's called here with respect to y. I combine them, it will be d square f and dy square. Okay, so that is a notation here I need to give it to you. What about fxy like this? fxy, here you have 1, and here you have 2. Start from the left 1 and 2. So what do you have? 1, so that is f sub x, and here outside y, so that is the first one you should really have, so which means df by dx, and then so that is f sub x here, and that is y here, right? So I could write here y here, after that is nothing but the partial derivative with respect to y for df by dx, which is, when I combine them, it will be d square f, and here dy, and here dx. All right, dy by dx. All right, so that is fxy. Now last one here, you have fyx. Start from the left 1, start here from 2 the right, so 1 2. So you must have first in your hand f sub y, that is number 1, and then you do, so that is 1 here, and that is 2 here. So which means you must have df by dy first, and then you take the derivative with respect to x. So here that is d by dx here, and here what do you have? You have df by dy, but you take the derivative with respect to x. All this notation here, and it will be d square f by dx and dy. All right, so what is the remark? A remark here is, in general, fxy is not equal to fyx. These are not the same. here f, so that is number 1 and that is number 2, and here number 1 and that's number 2. So fx here first, and then you take the derivative with respect to y, and here fy first, and then you take the derivative with respect to x, whatever you have here in your right. So that is what you have here. So that is what I have here for the df by dx. So let me give you some example here so that you have understand this, what I mean here for this partial derivative. So let us take simple example here. If you have f of xy equal to 1000 plus 5x minus 4y minus 3xy that is equal to minus 3xy. So that is your f of x. That is your f. Look what you have on the right hand side. Your f is a function in x and y. Your f is a function in x and y, and then I need to take the derivative of f with respect to x, and then I need to find df by dy. Alright, so how to do that? Step one by one. So df by dx here, it's nothing but it will be, what is your f? That is equation 1 here, df. So I have to take the derivative with respect to x. What is your f? It will be 1000 plus 5x minus 4y minus 3xy. So this one here, that is your f. That's come from equation 1. That is your f come from equation 1. Alright, so now I have to take the derivative. What you have in the middle, plus, minus, minus. So you have to take the derivative term by term. So you have the term, the derivative 1000 plus the derivative here 5x minus the derivative of 4y, and here minus the derivative here 3xy. So now here your f, you agree with me, f is a function in x and y, two variables. So if I take the partial derivative, that's called partial derivative with respect to x, means you consider other variable, which is our y. We treat y as a constant. We deal with y as a constant. So here, what is the derivative of any constant? 0. That's a constant. Derivative of any constant should be 0. So what is the derivative of 5x? That's 5. I can grab 5 outside. So what do you have left? The derivative of x with respect to x. Here, what is y? Y here is a constant because I'm taking the derivative with respect to x. So I consider other variable, which is our y, as a constant. So 4y here is a constant. What is the derivative? Any constant should be 0. So now here, well, that is the last one. Last one here, you have 3. It's a constant. I can take it outside of my derivative. Also, I consider y as a constant because I'm taking the derivative with respect to x. So I treat other variable, which is our y, as a constant, like 1 or 2, -1, just a constant. So here I can take the constant 3 outside, and then I can take y also outside. So what do you have left inside? Just x. So if I simplify this, what is dx by dx? Just 5, just to get 1, that is 1, and here also that is 1. So what do you get? You get 3y. So that is our partial derivative with respect to x. Partial derivative with respect to x. So now if I ask you what is the second derivative with respect to x, so that is the first derivative with respect to x, like f prime, right? So I need to take the second derivative, so which means that is 1 and that is 2. So I have first in my hand, I must have fx, which is already in this equation. So d by dx of the first derivative here with respect to x. That is our first derivative with respect to x. Then I have to take the derivative again with respect to x. So what is d by dx here? So what you have 5 minus 3y. 5 minus 3y, that is come from equation 2. That is equation 2, which is df by dx. So now what is, I'm taking the derivative with respect to x, and then I have to consider y as a constant. So 5 minus 3y, all of them, they are constant, because here I'm taking the derivative with respect to x, so your y here is a constant. So since you take the derivative of the whole constant here, then what is this one here? Give you 0. That is give you 0, right? That is give you 0 because the derivative of 5, 0. Here I consider y as a constant because I'm taking the partial derivative with respect to x, then that is 0, so the whole thing here you get 0. So now if I need to get fxy, that is number 1, fxy means you take the derivative. You must have in your hand f sub x, right? And then you take the derivative with respect to y. So there is one first, I must have that in my hand, which is already in equation 2. Equation 2, that is f sub x. So f sub x here, so f sub x here is which is just a copy from equation 2, 5 minus 3y, and I have to take the derivative with respect to y, which means the derivative with respect to y of 5 minus 3y. So I'm taking the derivative with respect to y. With respect to y, this partial derivative here, we call it funny, this d, it's a funny d here, just to let you know if here, or the function here, is two variables. So since I'm taking the derivative with respect to y, I have to consider x as a constant. I don't have any x here to consider. So what do you have in the middle? You have in the middle minus. So I have to take the derivative of the first one, which is 5, minus the derivative of the second one, which is 3y. 3y here, right? So what do you have? You have 0, that's a constant, minus, I can grab 3 outside. So what is you have inside? Just y. So what is dy by dy? You get here is 1. So what did you get? You get negative 3. Alright, that is our fxx, fxy. Alright, so when I take the derivative, now let us look for fy and fyy and fyx. Okay, so here that is equation 1, so I need to get f sub y. I need to get f sub y. So how to get df by dy? That is f sub y. So first you must have your f. So I'm taking the partial derivative, that's called partial derivative. This one we call it partial derivative with respect to y. Partial derivative with respect to y. So what is your f? What is your f here? Your f, I'm just copy f from up, which is just 1000 plus 5x minus 4y minus 3xy. So I'm just copy my f from up here. That is the one is given. Look what you have here. That is the one is given here. That is the one. I'm just copy that. So I write it down here. So I'm taking f sub y here. It will be the derivative of with respect to y, the first term, which is 1000, plus the derivative with respect to y, 5x, minus the derivative with respect to y, 4y, minus the derivative of with respect to y, 3xy. So here that is 0 because the derivative of any constant should be 0. What is here? I'm taking the derivative with respect to y, then I have to consider other variable, which is our x is a constant. So what is the derivative of this? It will be 0, right? 4, I can take 4 out, take 4 outside. So what do you have inside? dy by dy, which is 1, minus, take 3 out, you take 3 outside. So what do you have left? You can, I'm taking the derivative with respect to y, then I have to consider x here as a constant. I consider x as a constant. You can take 3x outside. What do you have left? Just y with respect to y. So that is your f sub y. What is dy by dy? It's 1. So what did you get here? You get negative 4 minus 3x. So that is f sub y. So now if I need to get let us give a number fyx. Fyx, that is number 1. That is number 2. Fyx, that is, we write it like this, dfy, right? And then the x and here dy like this, right? So that is, if I ask you to find this, then what you have? You have to go start from left 1 and 2. So fy, that is equation number 3, fy. So here you have fy between bracket and x outside. That is number 1. Come from equation 3 here, which is negative 4 minus 3x, and I have to take the derivative of that with respect to x. So which is the derivative with respect to x, minus 4 minus 3x. What do you have? You have in the middle here, so that is constant 0, negative 4, 0. What is the derivative of negative 3x? What is the derivative of negative 3x? It will be negative 3. It will be negative 3. Okay, so here, as you can see here, by accident, fxy, it turned out equal to fyx because both of them here negative 3, fyx, that is our fyx, but also up if fxy equal negative 3. Here by accident they are equal, but in general they are not the same. In general they shouldn't be the same. Okay, so that is one example here. I need to get fyy. Fyy, that is number 1, and that is number 2. What is fy? Fy, that is the one you should really know, you should have, and then that is after that, that's number 2, right? So fy is just a copy from up. Is just negative here. What you have, equation 3, negative 4 minus 3x. Negative 4 minus 3x, so negative 4 minus 3x, like this. So now I'm taking the derivative with respect to x, that is, sorry, with respect to y of fy, like second derivative with respect to y, second derivative with respect to y. So you have negative 4 minus 3x. So I consider x as a constant. So you have negative 4 minus 3x. The whole thing, they are constant. What is the derivative in a constant? Just 0. Just 0. So you have here 0. Okay. So that is one example here we give for the partial derivative. Let me give you another example here. If the other one is not clear, hopefully this one it will be clear. So you have several variables. F is a function of x and y. And here you have x e to the power xy, like this. All right, x e to the power xy, and I need to take the derivative of this one. So now, what is the question here? The question here, I need to find df. I need to get f sub x. Sometimes I write it like df by dx, like this. And also I need to write fxy, which means d square f by dy and dx dy. So I need to find those two here, so that next question here I switch to fyx. Okay, how you are going to do this one? All right, so it's one by one here. So I need to first, what is f sub x? Df by dx. So here I should have f somehow, so d by dx. F, what is your f? This one here, it means the derivative with respect to x. The derivative with respect to x. I'm taking the derivative with respect to x. Then I have to consider y, other variable, which is y. So here I'm taking the derivative with respect to x here. Then your y should be constant. So just to copy here, you have x e to the power xy, right? Xy. So here, which one is the constant here? I have x, your y, just your y is a constant. Like y here could be 1, 2, negative 1, negative 2, just a constant. And what is my variable here? X. So how to take the derivative of that? I just read it loud a little bit. X e to the power multiply x multiplied by e to the power xy. When you hear multiply, means product rule. You have to apply product rule. So what is product rule? F g prime. So it will be f g prime plus f prime g. So that is our product rule. So what is your f here? It will be x. But what is prime here? Prime means I'm taking the derivative with respect to x. Prime means the derivative with respect to x. So what is your f? It will be x. What is your g? It will be e to the power xy. So if I try to apply product rule here, f, which is x, g prime, what is g prime? So our f here is x, and our g here is g prime. It will be the derivative with respect to x for g prime, so that is xy, so that is your g prime, plus, so that is our g prime, and that is your f g prime plus f prime. What is f prime? The derivative with respect to x with respect to, so that is your f prime, that is our f prime. G, what is g? It will be xy, e to the power xy. Okay, e to the power xy. So that is your prime. So you can apply product rule here, but keep in mind your prime here is the partial derivative with respect to x, because that is a question. So now what is dx by dx? Is 1. Dx by dx here is 1. So I have here left. So now I need to figure out what is the derivative of e to the power xy, like this, right? So that is exponential functions. What do you know about y? Y here is a constant. So let me recall for you here what is the rules of exponential. Rules of the exponential should be the same, exactly the same. ln b multiplied by the derivative of exponent, f prime, the derivative of exponent. So what is your b? When I compare, your b here is e. Your b here is e. Prime here means you take the derivative with respect to x. So here, if I compare e to the power xy, d by dx, so what is your b is e, so derivative any exponential should be exactly the same, ln e, which is, what is your b? E. Your b here is e, and then f prime, which means the derivative with respect to x. What is your exponent here? Your exponent here, x multiplied by y, x multiplied by y, right? So what is ln e? Ln e here is 1. So what did you get? You get e to the power xy. And now I'm taking the derivative with respect to x. So what is your y? Or your y, I consider y as a constant. I consider y as a constant. So y, I can grab it outside. I can grab y outside. So what do you have left? dx by dx, which is, what is that? That's 1. So what do you have? Dx by dx, you have 1. Y here is a constant. I treat it as a constant because you take the derivative with respect to x. So you have your x here, that is our variable, and the other variable, which is y in our case, it will be a constant. So I grab it outside. So like, it's like when I ask you, what is the derivative of 3x? Tell me 3. So what's the derivative of y, which is a constant multiplied by x? It will be y. Because if the derivative of 3x, which is just 3x prime, what is that? It will be 3. Then the derivative of y multiplied by x should be y. So I go back to the rules here because that is a question. I need to get df by dx. So here, product rule, that is our product rule here, right? Fg here. So you have x here, and the derivative of this one here, it's already, you have that here, which is e to the power xy multiplied by y. So the derivative with respect to x, this one is y multiplied by e to the power, that is y multiplied by e to the power xy. So that is our product. So now here, what do you have here? You have e to the power xy, right? E to the power xy. So if you want to simplify, some people say, can I simplify this? Yes, you can leave it like this, is okay. I'm happy for here, but if you would like to simplify, then what you have, you factor out this one here, this term, it's already here. So if I grab e to the power xy outside, so what you have from here left, x multiplied by y. When I take this one here out, what do you have left? Just 1. If I take from here, you get 1. If I take from here e to the power xy, you have what is left, x, what is left, y. So that is your f sub x. Yes, that is our f sub x. That is a partial derivative with respect to x. Alright? So, or you can leave it like this. Okay? So what is the question here? fx here, I figure out this. I need to figure out fxy. I need to figure out fxy, and then we are done. Okay? So let me do that. fxy. So fxy. I said that is number 1 and that is number 2. So fx, that is the one you should have first. This one, that is, and then you take the derivative with respect to y, that is number 2. So that is 1 and that is 2. So fx here, already I figured out. Let me give this equation number 2, that is a partial derivative with respect to x. So I have to take the derivative with respect to y of df by dx. That is the one you have in number 2. So what do you have? You have d by dy, number 2, which is e to the power xy multiplied by xy plus 1. I close the bracket. So that is your come from equation 2. That is come from equation 2. F sub x. What is f sub x here? That is f sub x come from equation 2, which is e to the power xy multiplied by xy plus 1. Just I copy here. I copy here. So this one, f is x. So 1, I have to get the partial derivative with respect to x, which is already I did. That's, I call this equation number 2. And then 2 here, after you take the derivative with respect to x, you have to go ahead and find the derivative with respect to y. You have to go ahead and find the derivative with respect to y. Alright, so here, how to get the derivative with respect to y? Again, here, I consider, I'm saying, what is my variable here? Y. I'm taking the derivative with respect to y, and then I should consider x here. Our x here is a constant. What is your x? So I put circle around x, so that is x constant. But you have e to the power xy multiplied by xy plus 1. So here again you are going to apply what's called here product rule. So that is how to apply product rule. That is your f and that is your g. So what is the product rule? It will be, if I take the derivative of this, it will be f g prime plus f prime g. But what is your prime here? Your prime here is the derivative with respect to y. The prime here means that is your f multiplied by g prime. So our case here, the derivative with respect to y, the derivative with respect to y, the derivative with respect to y. So what is your f? Your f here is e to the power xy. What is your g? The bracket. So here the fxy, the derivative, it will be, I'm going to apply product rule, which is e to the power xy. The derivative with respect to y, that is your prime of xy plus 1, right? Xy plus 1 plus the derivative with respect to y, e to the power xy multiplied by xy plus 1, all right? Xy plus 1. So now, let us look for what you have. Let us do that one by one. Here again, I'm repeating, what is the derivative here? The derivative with respect to y. With respect to y, then your x here is a constant. What do you have in the middle here? What do you have in the middle? You have plus here, that is plus. So you have to take the derivative of the first term plus the derivative of the second term. The derivative of the first term plus the derivative of the second term, right? The derivative of the first term here plus the derivative of the second term. So now here, what is the derivative of this one here? Did you figure out before? Yes. Let us maybe I have to do it again, so which is okay. So how to do the derivative here? I need to get the derivative. I need to get the derivative with respect to y for e to the power xy, right? So since what is the rule here, guys? The rule here, the derivative of b to the power f should be b to the power f multiplied by ln b multiplied by f prime. That is the rule. I'm going to give it to you here, prime. So derivative any exponential should be exactly the same, ln b f prime. So what is your f here? xy. I'm taking what is your prime? Your prime derivative with respect to y. So if I do that, so what is your b? E. So derivative any exponential should be exactly the same, and ln e, that is your b, which is 1, and I have to take the derivative, that's f prime, which is the derivative with respect to y. What is your exponent? Xy. So now let us finish from this. ln e here is 1, and now I'm taking the derivative with respect to y. Your x is consider x as a constant, so you grab x outside. So what do you have left inside? You have y with respect to y, which is 1. So what is the derivative of this? It will be x multiplied by e to the power xy. So if I go back here, applying the rules, so what is the derivative of e to the power xy with respect to y? I just copy from here, which is x e to the power xy. So I have to copy this x e to the power xy, and here multiply by xy plus 1. xy plus 1. So now, what is the derivative of 1? 0, because it's a constant. Here, I'm taking the derivative with respect to, okay guys, so here the derivative 1 is 0. I'm taking the derivative here with respect to y. Then I consider x is a constant, take x outside. So what do you have? You have xy. I'm going to take x out, you have that. And here you have x e to the power xy and xy plus 1. Just leave it like this here. You don't need to simplify. I'm happy just I do it like this. So here again, here it's very important here to go ahead, and I did first f sub x, the partial derivative with respect to x, and then I consider y as a constant, and then I here in our example I apply product rule, because you have, what is your function here? X multiplied by e to the power xy, which means you have x multiplied by e to the power xy. Then what do you have? You have product rule, and that is what I did. I applied product rule, but I keep in mind the prime for product rule here, the derivative with respect to x. And then I repeat the same story here. The question, what is fxy? Fxy means you have to get fx first, and then number 2, you must have in your hand f sub x, and then you take the derivative with respect to y after that. So that's what I did. Did I figure out f sub x? Yes, it's equation 2. F sub y, then I have to take the derivative of with respect to y, but for f sub x. So the whole thing here, f sub x, the whole thing. Then I am going to apply product rule again, but the product rule in this time, you take the derivative with respect to y, and then it will be nice. So that is, it will be over here, just apply product rule and then just keep continue. All right, guys. All right, so let me give you another example here, and then I kind of finish this part here, and then maybe I give you one related to log, and then we have to maybe give you. So let me show you here what is the question. They ask you to find, there is a question, find, maybe I write it down here. So the question here, maybe I take a room for myself here because I need to write. So I take, just move it a little bit, okay. Okay, so here, I'm just going up here, all right. All right, so here, what is another example here, guys? So they ask you to figure out, if I ask you f of xy, f of xy equal to y log, will be ln y ln xy, like this, xy, okay? You have y multiply by ln xy. So some people say, well, can I, let me ask you a question here. Can I use law of log to simplify this? Yes, you can. Some people, they don't like to simplify, is okay too. So how to simplify this? It will be y. What is recall here? Let us recall. So what do you have? You have log a multiplied by b. It will be log a plus log b, right? Log a multiplied. So here you have y. If you have log x multiplied by y, can I write it as log x plus log y? Can I do that? Yes, you can. So ln x multiplied by y, it will be log x plus log y, because that is, if you have log a multiplied by b, it will be log a plus log b. Okay, guys. So now what I have here is kind of y log x. So now I need to get df by dx. How to get df by dx? Df by dx, so I have to take the partial derivative with respect to x. So what do you have? You have y, open bracket, ln x plus ln y, right? So that is our f. So that is equation 1. Our f here, that is the 1. So what do you have in the middle? You have in the middle plus. You have in the middle plus. So if you have in the middle plus, so you could take the derivative of the first term, which is y ln x, plus the derivative with respect to x, y multiplied by ln y, right? So here, because y multiplied by ln x, you have y ln x, right? Y multiplied by ln y, you get y ln y. So now I'm going to take the derivative with respect to x. So which means your y here become constant. I can grab y outside. You can grab y outside. So what you have inside, it will be ln x, like this, right? ln x. Right, so that is a partial derivative with respect to x. Because y, I consider y as a constant, I grab it outside, you have that. So now what you have here, I consider y as a constant, and here that's a constant. The whole thing here is constant. If you have y equal 2, right? So what you have 2 multiplied by ln2, which is ln2 is a constant. So what is the derivative of this? The derivative of this, it will be 0. The derivative of that is 0. If I simplify this, what is the derivative of ln x? So ln f, the derivative of this one here, it will be 1 over f prime, 1 over f prime, 1 over f prime. So what is your f here? It will be y outside, inside here 1 over x, and x prime. So the derivative of x with respect, so f prime here, I'm taking prime, the derivative with respect to x. So if I simplify this, you get y over x. If I simplify this, you get y over x. Okay, so now if I ask you what is f sub y, or maybe I finish here first, fxx. What is fxx means? It's the second derivative with respect to x. So what is the first one here? So the first derivative, that is f sub x, that is your df by dx. So sometimes they ask you like this, they write this notation, means the second derivative with respect to x. So now what is my first derivative? My first derivative, it's y over x. So that is the equation 2, y over x. So I have to take the derivative of the first derivative. So this one, if you want, I could write it like this: d by dx, df by dx, like this. Okay, so d by dx, df by dx, which is what is that? It will be y over x, y over x. So now, what is y over x? How to take the derivative of this? What is your, I'm taking the derivative with respect to x. Then what is your y? Y constant. I consider y as a constant. I treat it as a constant, right? Constant. So I can grab y outside. So what do you have left inside? 1 over x. How to take the derivative of this? That is quotient rule, or you could simplify to make it like this. The derivative, I could write x to the 1 negative 1. Take x to the power 1 up. You have x to the 1 negative 1, right? So it will be the derivative y. What is the derivative? It's x minus 1 minus 1. So I put that is your n, negative 1, n minus 1. So what do you have? You have negative y x minus 2. So which is, you can leave it like this, or you can make this one as negative y over x squared. Negative y over x squared. And that is our second derivative with respect to x. That is the second derivative with respect to x. All right, so that is your fx. So now if I ask you, what is f sub y? F sub y, that is the partial derivative with respect to y. Then what is your f? So I have to go up. What is your f? You know, just copy up here. So what do you have for this one? Y multiplied by ln x plus, I simplify this equation 1. So I have to write it down. So if, let me write it here. If some people, if you don't simplify, what will happen? If you don't simplify, what will happen? So let me do this one here. So that is your f. That is what is given. I'm taking the derivative with respect to what? Y. I'm taking the derivative with respect to y. If I take the derivative with respect to y, then I have to consider x as a constant. So you have y multiplied by ln xy. So here I don't have any option rather than, did you hear multiply? Y multiply means a product rule. Fg prime, it will be Fg prime plus F prime G. So what is F here? It will be y ln x y prime. So what is that? Your prime here, it will be y ln x y prime. Maybe I should write it here. So let me do that here one by one. So if you have f g prime, that is our product, it will be f g prime plus f prime g, right? So here, what is your f? It will be y. What is your g? ln x multiplied by y, the whole thing prime. So what is your f? That is your f, and that is your g. So your f, it will be y. What is your g? xy prime plus f prime, which is y prime, g. What is your g prime? So here it will be ln x y, right? So that is your f, that is your g prime, and here that is your f prime, and that is g. But what is prime here? Prime here means the partial derivative with respect to y. Partial derivative with respect to y. So if you want, you can write it like this: the partial derivative with respect to y, ln xy, right, plus y prime, which is y prime, like this, and multiply by ln xy, right? So I switch from prime to partial derivative with respect to y. What is that? That is 1. That is 1. So what you have ln xy, and then I have to apply the derivative. What is the derivative of log here? It will be 1 over f, that is your f, multiplied by f prime, that is f prime. So 1 over f, and this one here, we call it f prime. So ln f, it will be 1 over f multiplied by f prime. That's the rule. So now I'm taking the derivative with respect to y. Then I have to consider x as a constant. So take x outside. So that is f sub y. I have y, and here, look, you have y here, cancel with y. 1y cancel with 1y, you get 1 over x. And here I can take x outside, right? So what do you have left? The derivative y. And what do you have here? ln xy. What's this one? Is 1. X here cancel with x. What did you get? You get 1 plus ln x multiplied by y. All right. ln x multiplied by y. That is the partial derivative with respect to y. Alright, so that is the partial derivative with respect to y. So let me repeat that again. So you have here y cancel with y, you get 1 over x. Here I am taking the derivative with respect to y, then x is a constant, I can grab x outside, but x here cancel with x down here, so x cancel with x, you get 1. What is the derivative of y with respect to y is 1, and here that is what is left, so that is fy. So now if I ask you what is fyy, fyy means the second derivative with respect to y, second derivative with respect to y. Okay guys, the second derivative with respect to y, so which means what is the first derivative, and then after you take the first derivative with respect to y, number 2 you take the derivative again with respect to y. So that is the derivative with respect to y. We write it like this, right? Or we write d by dy with respect to y. So I'm taking the derivative here, that's the first derivative, that is the first derivative with respect to y, and then I'm taking, that is like funny d or partial derivative. So here the derivative with respect to y, what is that is equation, just let me give a number, equation 3 or 4, just 4, it will be 1 plus ln xy, right? So what do you have in the middle here guys? You have in the middle plus. If you have in the middle plus, what you have, so that is f sub y. So you take the derivative with respect to y1 plus the derivative with respect to ln xy, and then there is 0 because it's a constant. I'm taking the derivative with respect to y, then I consider what is that, it will be 1 over f multiplied by the derivative here x multiplied by y, right? So that is f prime and that is f, so 1 over f prime. So if I simplify this, so what is your x here guys? X, I take the derivative with respect to y, then I consider x as a constant. Consider x as a constant, take x outside, so what do you have inside? Y with respect to y, which is 1. X here cancel, so what do you have? You have x over xy, that is 1, right? So 1x cancel with 1x, you get 1 over y, and that is my second derivative with respect to y. Okay guys, that is the second derivative with respect to y. So now if I ask you what is your fyx, like this, right? fyx. So what is fyx? So if I try to find this, that is number 1 and that is number 2, right? So here means I have to have in my hand f sub y first, and then I have to take the derivative with respect to x. What is f sub y? F sub y, that is come from equation 4, that is f sub y 1 plus ln xy. So I have to write it down, so you have 1 plus ln xy, the whole thing with respect to, so that is fyx here, right? So that is f sub y come from equation 4, that is come from equation 4. So which means I'm taking the derivative with respect to x of 1 plus ln xy, like this, right? What do you have in the middle? What does you have in the middle is, that is fyx, right? So you have in the middle plus, so you take the derivative term by term, 1 plus the derivative with respect to x ln xy, like this. So that is 0, that is 0, and here xy, it will be, that is your f, it will be 1 over xy, and f prime, but the derivative here prime with respect to x, prime here with respect to x. So if I take the derivative with respect to x, what is your y? Y constant, I can grab y outside, and here you have x over y, and what is left here when I take y outside, you have dx over dx, which is 1, dx by dx, which is 1. So what do you have? You have here y over xy, I can cancel 1y with 1y, so what did you have? You have 1 over x, 1 over x. Okay guys, so that is very much the partial derivative. The idea, this partial derivative here, I'm taking your f is more than one variable. If you take the derivative with respect to x, then means your x here is a variable, and your y, I consider y as a number, as a constant. And if I take the derivative with respect to y, then I have to consider other variable, which is x, as a constant. That is the idea from the whole, from this section here, or from the whole thing. Okay, so next time I will give you application of this partial derivative. All right, thank you. I will stop here.